Hello, how's it going? I'm Jane Galt, and I made this little demo to sort of help demonstrate how math relates to games, specifically in terms of like algorithms to create sort of physical behavior. So what I have this sort of little classic platformer looking thing. It looks like Mario Original, where you basically have this notion of jumps and also you move around, and I just wanted to sort of go through how that sort of works. And uh, what I've built into this is this whole concept of you actually have uh, the central code that I put in for the update loop. So the update loop occurs basically as a matter of every time the game has to run, it'll run essentially a update that looks at your inputs of like what your buttons you're pressing, and then update the physical properties of the world that then translate into things getting rendered to the screen. So the idea is it's like you press a button to jump, your the computer model would know like, okay, I need to start moving this character upward, and then it would render this sort of the modeled character wherever that new position was determined. Um, and so within that, I have uh, basically two views of the code. You have sort of the raw code where this is exactly what well basically what I have as the code for allowing the character to move around side to side and jump, and also a version of it that um, you can then see as sort of the pseudocode version of where it's like if I were to sort of the basic expression of what each of the individual lines of code is doing. So this stuff, the pseudocode won't run, but it sort of helps explain what's going on. So if you're ever not sure of what I'm sort of doing, you can sort of flip back and forth between the two to figure out sort of what's going on. Additionally to that, I also have these sort of parameters that allow you to control things. So you can control speed of like the X speed is sort of your horizontal movement speed, and the jump speed sort of your when you're coming off the ground, what sort of force you're using to get off the ground, and then gravity ends up being sort of the rate at which you reach sort of your pinnacle of your jump, and then also fall back. So, uh, like playing around with those allows you to create all these different sorts of behaviors. I came up with this. It's fairly slow, fairly basic movement, but you can do things like turning up the speed, and now I'm super fast, right? It's not like the hedgehog, right? Super fast. Or you could slow that down and slow that down, and turn up gravity. Get gravity. And now it's like I can't jump nearly as high, and we lower that like down to like reasonable limit. And now it's like I'm on like a very low jump. Can't get it anywhere. On top of that, I also have this notion of you can actually view the trail that for like about the last 5 seconds. So you can see this is sort of where the math comes into it of this path that the character is going is actually being created by our algorithm. And so by putting things at their levels, you'll see now we get these shapes. So sort of this is what the code ties in of what are these shapes that allow us to uh, be able to move in these directions. And this comes into the sort of the math background that all of this ties to. Um, and so the basic code for it now that as we'll go over it is this idea that we first want to sort of break it into these three main parts of what we're going to do for moving the character around. So as you can see, uh, with there's the side to side movement as well as jumping. So you can basically what I'm doing is I essentially have this. Just remember that every time you see these like double slashes, that just simply means this is a comment. The computer's not going to run that. That's just something that is in the code to help people take notes, so that anyone else looking at the code can understand it. But what I'm basically doing is for this first block is I'm getting this input axis of horizontal. So that could be a joystick, or that could also be what I'm using is with the keyboard is A and D translates into this one axis. And so what that does is it basically gives it so the idea that if I press A, I'm getting out a negative number, and if I'm pressing D, I get a positive number. So they're basically pointing in these two different directions. So as I move side to side, I like as I press D, I know I'm moving in the positive direction, and A, I'm moving in the negative direction. And I take that and I apply it to this sort of this velocity uh, that it essentially controls your horizontal movement. So velocity in the x direction is your left and right direction. Um, so I take that, I'm applying the direction sort of scalar, which is usually going to be somewhere between -1 to 1. And then I'm multiplying it by the x speed, so the speed that we set in our parameters, so that it'll scale up or scale down depending upon if we want our character to be fast or slow. Then the next step is this sort of taking into account sort of changes for our uh, being able to jump up and down in the air. And so what we do for that with the velocity is we are taking the idea that we're sort of branching based on if the character's in a situation where they trigger a jump and the situation like all other situations. So basically the situation where you would trigger a jump is if you are if the character is on the ground, and that's sort of what this thing is checking for. This char controller is grounded, and then also if the person presses the jump button, and so if those two constraints are met, it'll fall into this block uh, that'll actually run setting this sort of basically the way I'm doing it of setting the velocity directly this way is sort of this impulse velocity that will then be sort of accounted for later on with when we do gravity below it. So uh, basically, uh, as we get this situation of we're jumping, it's going to use jump speed sort of as this acceleration to go taking essentially whatever jump value we have, which is in this particular case 12, and applying it directly, which will cause us to have this very huge rise. And so then on the next couple frames that come in, that's where this else comes in, is basically after we've sort of run through once and now we've come back around again. And if I press the jump and I'm in the previous frame, I should be off the ground at this point. Um, and what we then apply is sort of this standard integrator for um, velocity, which is the formula is velocity is equal to acceleration times time plus whatever the previous velocity was, which is just sort of a normal kinematic movement algorithm. Um, and so what you get with that, well, what we're specifically doing with that is we're using that to account for gravity. So gravity is, or negative gravity is our acceleration in that formula. And then time dot delta time happens to be our, uh, basically our increment. So basically between the last update and the current update, that the amount of time that has changed is represented by this time dot delta time value, and then adding in our previous velocity. So what that happens is when we come into the first block and we do our jump, and we now have this force going up, and what this is going to do is the second block is going to help create that shape of this sort of arced jump. So as you can see with how it's sort of like I'm able to go up and I hang in the air for a little bit before I start coming back down. Um, and it's somewhat symmetrical in shape. And so what you're getting is that the velocity, as soon as you press jump, starts really high in the positive direction. And then every time we come around, it's going to slowly and slowly decrement it until it slows down roughly in the air and you reach this peak where he hovers around, and then it starts accelerating more and more and more in the downward direction until you come in contact with the ground again. Just basically how a lot of games sort of do it. And then this last final step is just the basic, like you're now taking the velocity and applying time to it to account for its normal integrator for position is equal to velocity times time plus the previous position. So sort of similar to what we just did with gravity. And what I sort of this sort of simplifies things a little bit because essentially what needs to happen that I sort of do as like this extra chunk of code is this rather than taking this calculation and directly applying it to the position, what I have to do is actually run this change in position through basically collision code. So that'll do things like determine if like I'm falling, and if a block comes in my way below me, I'm going to hit the ground and stop rather than passing through it. Because if I didn't run those collisions, I'd completely pass through everything, and there'd be nothing that could block the character from sort of moving. So similarly, if I run into like the side of something, it'll stop that. So that's basically the gist of it. Have fun playing around with it. Let me know if you have any questions or in the comments, as well as if anything else you'd like to see more explained with this kind of thing. This I threw together pretty easily, and it's sort of just fun to play around with. Let me know, yeah, what you think, and I hope you have fun with it. All right, thanks.